Hey guys, once again, I am not in class today. I have meetings today. So you should have already had a sub. You should have already taken your quiz for today. You should have turned your homework from last class into the tray. I will go over that homework next time when I see you on Friday. So I will grade it. I will take a look at it and grade it. And then we'll go over it on Friday. I'll give it back to you and we'll go over it. Okay? The quiz, hopefully you did well. It should have only taken you about 10 to 15 minutes to do. If you took a little bit longer, fine. But by now, you should have already been finished with the quiz because now you are getting ready to watch my video of the notes. So the important part is to pay attention to the details in the video where I talk about the homework problems and how you will need to solve some of them. I know that the notes get kind of boring when you're watching them on a video and it's easy just to fast forward through them. But on some of them, you're really going to need to listen to what I tell you about the homework. Okay, so make sure that you're really paying attention to that and listening. Otherwise, you're not going to know how to do some of those homework problems. If you are listening now, I'll kind of give you a heads up on some of the problems on your homework. For example, numbers, and you don't have those in front of you, but like for numbers 5 through 8, you're going to have to round to the nearest hundredths place before putting it into your scientific notation, okay? So once you divide those numbers out, round them to the nearest hundred or thousandths place, sorry, not hundredths place, thousandths place, and then put them in scientific notation, okay? All right, well, here we go. So you're going to watch the video, then you're going to work on your homework, and then I will see you on Friday. So have a great day and enjoy my lovely video. All right, so today we're talking about scientific notation. And so scientific notation makes it easier to work with numbers. Scientific notation form is in the form a times 10 to the b power. So what that means is scientific notation is used to make very, very, very large numbers easier to work with, or very, 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 very small numbers easier to work with. So for example, if we look at the diameter of the solar system, that's a pretty large number. And so to write that out all the time, it gets kind of monotonous. So what we're going to do is we're going to use scientific notation to represent that number. And to make this into scientific notation, this is where we have to start with our decimal point, and we're going to count how many places it takes to get back to the first number. Okay, so our very first number has to be between 1 and 9. So this number is a number 1, so I'm going to place my decimal right after that. So I have to count how many places I'm going to go back. So that would be 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to stop right there, right before the 1, and I'm going to write it 1 point. I'm going to write all the numbers that I need except the 0. So all the other numbers except 0, I'm going to continue to write. So 1.18 times 10, and I moved it 8 places to the left, so that's going to give me a positive 8. So when we move to the left 8 places, it's going to give you a positive, can't write today, it's going to give you a positive exponent. Okay, so that's what that looks like. So let's try it on this one. This is a really large number. where our decimal point starts here at the end. Okay, I only want one digit, so my decimal point has to end up right here. And this one digit has to be between 1 and 9. It can't be any larger or smaller. It has to be between 1 and 9. And it is. It's 4, so we're good. So now I have to count how many places it goes back. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I'm going to write all of the number parts. So 4.709. And then the rest of that is going to go away, and that's when I'm going to put times 10 to the 9th power. And that one went to the left 9 places. All right, so those were two very, very, very large numbers. Now we're going to look at some small numbers, some really small numbers. So this one, okay, is the same rule, okay? You have to have a number between 1 and 9, it's the decimal place. So we're going to move our decimal place to the first number that we come to. So 1, 2, 3, 4. So that is the first number right there. 1 is the first number between 1 and 9 that we come to. Then I'm going to put my decimal place after. So I'm going to write all of my digits, 1.52 times, and now because this is a really, really, really small number, we have to use negative exponents. So I moved it 1, 2, 3, 4 places. So that means I'm going to have 10 to the negative 4 power. Okay, so we moved it to the right 4 places. And since we went to the right, it gives us a negative exponent. Okay. I know I'm going kind of fast because I don't want the video to be super long. So if you have to rewind it, you can, and watch it again. Okay. All right. This one's super, 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 super small. So this is actually the diameter of a silver atom, okay, whatever that is, right? Okay, so we want our decimal point to go right here because we need one number, one whole number between 1 and 9 to be in front of the decimal place, and then every other number goes after the decimal. And then we got to find out how many places we moved to get our decimal point to that place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places to the right. So that's going to make it 2.5 times 10 to the negative 13. So I went to the right 13 places. And that made it a negative exponent. So when you go to the right, it makes it a negative exponent. When you go to the left, it makes it a positive exponent. And just think, really, really, really big numbers have positive exponents. Really, really, really small decimal numbers have negative exponents. Okay? All right. So write each number in scientific notation. Go ahead and pause the video, and I want you to try these two. So take a minute, pause the video, try these two on your own, and then play the video and see if you are correct. All right, so I got 5.812 times 10 to the 10th power. And for B, I got 7.2 times 10 to the negative 7 power. If you didn't get those answers, go back and check and see what did you do wrong. Did you count wrong? Did you not put your decimal point in the right place? Okay, so go back and check those and see if you did any of those things wrong. All right, so now that we know how to write each number in scientific notation, now we're going to write each number in standard form. We're going to work backwards. Okay, so we're given scientific notation and now we have to work backwards. What does that mean? So if I have a positive exponent, that means I'm going to go the opposite direction now. Okay, so I'm going to be adding zeros onto the end of my number. Okay, so I'm going to write my 4, okay, because that's where my decimal point starts at 4 points. Now I'm going to count the numbers that are there. So it's 9, 5, that's 1, 2, and I need 8 total numbers after my 4. So 9, 5 is 1 and 2, 3, 4, 5, 6, 7, 8. So I had to add 6 zeros in order to make that 10 to the 8th power. So now what my number is 495, comma, 000, comma, 000. So there are 6 zeros plus the 95. That gives me 8 total numbers. Okay? All right, this one, 7.63 times 10 to the negative 5. So I know because it's a negative, it's going to be a really, really small number, and I'm going to have to move my decimal to the left. Okay, this one, I added numbers to the right. This one, I'm going to have to add numbers to the left, okay, to put in front of. So I already have one number in front. That means I have to add how many more zeros to get to 5, negative 5. So I'm going to add 1, 2, 3, 4. 7 is my 5th number. 6, 3. My decimal point is here. I can add a 0 in the front. So I have 4 zeros and then my 7. That's my 5 number, my 5 extra numbers that I added in. So that's going to be in front of or before the 7. Okay, hopefully this is making sense to you. And I know this is review, so it should be a little bit easier. Okay, all right, looking at C. 4.95 times 10 to the 0. 10 to the 0, remember, we know that to just be 1. So our answer is not going to change here. It's just going to be 4.95. Okay? All right. Example 3. Is the number in scientific notation? If not, write it in scientific notation. So remember, for it to be scientific notation, it can only have one number and then the decimal point. So looking at this, how many numbers do we have before the decimal point? We have 2. We need it to only be 1. So that means we have to move our decimal point back a place. So that's going to give me 2.31. Okay? And when we go back, so I want you to write this down. Go back 1, you're going to add 1 to your exponent. So when you go back 1, you're going to add 1. So we went back 1. That means we have to add 1 to our exponent. That's going to be 10 to the 4th power. That makes it in scientific notation. So we always have to convert it. So no matter what we get for our number, if we get something that's not with only one decimal place, then we have to convert it and change our exponents. Okay? This one for B. Is this in scientific notation? How many decimal places do we have in front of the decimal? We only have 1. So this one looks good to me. It's already in scientific notation, so we don't need to do anything with it. It's good the way it is. Okay, because we only had one number in front, and that's all we need. All right, looking at C, 0.7. Do we have one number that is between 1 and 9 in front of the decimal place? No, 0 is the one that's in front, And that is not a correct number, so we can't use that. So we're going to have to move our decimal place 1 to the right. So when we go to the right, we have to subtract. So when we go to the right, we subtract an exponent. So that means I'm going to have 7 times, I'm going to subtract an exponent, 10 to the negative 5th power. So negative 4 minus 1 is negative 5. So I had to subtract an exponent. All right. Hopefully this is making some sense to you. Know the rules. Just keep applying them. So remember, if we go back 1 or to the left 1, okay, go back or to the left, we have to add 1 to our exponent. If we go to the right, if we move our decimal place to the right, we have to subtract an exponent. Okay? All right, example 4. This is where we are dividing our scientific notation. And you are going to need your handy dandy calculators for this, so hopefully you have them with you. You should start bringing them to class with you every class period from here on out because you're going to need them for a while now. Okay, so what we first have to do is we're going to have to look at our numbers first. This says to divide 3.2 by 2.0. So if you put in your calculator 3.2 divided by 2.0, that gives us 1.6. Okay, so we divided that. And then we're going to follow the rules for dividing exponents, just like we did on our last assignment. When we divide exponents with the same base, our base is 10. So that means we're going to take 10 and we're going to subtract our exponents. We get 7 minus 4. So that's going to be times 10 to the 3rd power. So your exponents are going to just be subtracted just like we normally do when we were working with exponents, properties of exponents. Now we have to look at this. Is this in scientific notation? Yes, it is, because we only have one digit in front of that decimal place. So 1.6 times 10 to the 3rd is a great answer. Now, I'm going to tell you this on your homework. You might not get such nice numbers that divide out so evenly like this. So, for example, you might get something like, let me find your number 5 on your homework. So number 5 looks like this. 9.1 times 10 to the 0 over 8.5 times 10 to the negative 6th power. Okay, so 9.1 divided by 8.5, that equals a big long number, 1.07058824. Now we don't really need all of those numbers. So what I'm going to tell you to do is to round to the nearest hundredths place. So 3 decimal places out, we're going to round to that decimal place. So 9.1 over 8.5 is going to equal 1.071. Okay? So that is where I want you to round it to, 1.071. So when you are doing your homework, most of those ones in section 5 through 8 are going to have to be rounded like this. Okay? So that's one of the important things I wanted you guys to note, that those have to be rounded. Don't try to write out all of these numbers in scientific notation. Okay? All right. And then if we were to finish this, I'll finish this one with you. So if we look at this, our answer is going to be 1.071 times 10. We have to subtract our exponents. So 0 minus negative 6 minus a negative changes to positive. So that's going to be 10 to the 6th power. Okay? So number 5, if you paid attention to this video, on your homework is already done for you. All right, so let's look at B. (27 times 10 to the third divided by 54). So 27 divided by 54, if you put that in your calculator, you're going to get 0.5 times, and now 3, we're going to take 10 to the 3, so we do 3 minus 7 is going to give us -4. So this is times 10 to the -4th power. Now with exponents, this is a little bit different than our power or our quotient rule and our negative exponent rules. Okay, for scientific notation, we can keep negative exponents. Okay, we don't have to move them or get rid of them because this is scientific notation. It's okay to have these negative exponents. All right, but when we're just talking about properties and we're trying to multiply them or divide them or use the quotient rule and the product rule and all of that, then we have to get rid of all the negative exponents. But scientific notation allows us to have negative exponents. That just shows us that they're really, really, really small numbers. So we don't want to get rid of those negatives. We want to keep them. All right, for B, is that one completely done? Is it in scientific notation? It is not in scientific notation because (0.5) is not having a number from 1 to 9 in front of the decimal. So we have to move the decimal so that the 5 is in front. And then when we move the decimal to the left, we have to subtract 1. So that's going to give us 10 to the -5 power. So that should equal 5 times 10 to the -5th power. Okay? And then C, if we divide 1.72 divided by 2.5, that's going to give us 0.688 times 10. We have to subtract exponents. We have -6 minus -2. That's going to give us -4. So we have 10 to the -4. However, this is not in scientific notation, so we're going to have to move our decimal place 1 to the left, which means we're going to subtract 1. So you're going to get 6.88 times 10 to the -5th power. All right, so far so good. I hope you guys are getting this. Number 4. So now we just finished the quotient in our dividing standard form, and now we're going to be multiplying standard form. So same thing with division. When we had the whole numbers, we just divided them. Now we have our whole numbers. We're just going to multiply those numbers together. So we're going to multiply 2.5 times 6, and that's going to give me 15. Okay, times, and we're going to follow the same rule, 10 and 10. When we multiply powers, we add exponents. So this is going to be 3 plus 2, so that's going to be 10 to the 5th power. Now 15 is not in scientific notation, so my decimals here, I'm going to have to move it back 1. Back 1 adds 1 to my exponents. So this is going to be 1.5 times 10 to the 6th power. So the biggest thing to remember, if you remember back 1 adds 1, kind of rhymes with each other maybe a little. Back 1 adds 1, then you know if you go the other way, then you always have to subtract. So if you remember the back 1 add 1, then you know that you're going to be on the right track every time. All right, for the next one, we have 15 times 4, so we're going to multiply those together. We get 60 times 10. We're going to add our exponents, so we have 2 plus -4, which is going to give us -2. 60 is not in scientific notation, so I'm going to put my decimal. I have to go back 1 and add 1. So that's going to be 6 times 10 to the -1 power. For F, 1.4 times 5.1. That's going to give me 7.14 times 10 to the negative 3 plus negative 2. So negative 3 plus negative 2 is negative, oops, I forgot to put my 10, times 10 to the negative 5th power. Okay, and then this is already in scientific notation, so 7.14 times 10 to the negative 5th. All right, now we're going to look at when you have like power to power scientific notation. So this is where we're going to multiply the powers. So the same rules apply. We're going to take the 2 and we have to distribute it to the 3. Remember, this is 3 to the first power. So we're multiplying our powers. 1 times 2, which is 3 to the second power, times 10 to the 2 times 4, which is 10 to the 8th power. Now we're going to have to evaluate 3 squared. So that is going to be 9 times 10 to the 8th power. 9 is already in scientific notation because if we put our decimal point there, it fits with what we need it to be. And 10 to the 8th is good, so we just leave it like that. 9 times 10 to the 8th power. Okay, and then this one. We have 4, remember 2 to the first power, so we're going to put our 4 to the first power, so 2 to the 4th, times 4, or 10 to the negative 12th power. So it's negative 3 times 4 is negative 12. Evaluate 2 to the 4th. So 2 to the 4th is 16 times 10 to the negative 12. There's nothing that we need to change. Oh wait, there is something we need to change on that one. So 16 is not in scientific notation. So our decimal point would go here. We're going to go back 1. We have to add 1. So that's going to be 1.6 times 10 to the negative 11 power. All right. So that is how we do the power to power ones. Now we're going to look at kind of combining a couple of those together. So the first one, we have our multiplying. So we're going to do it just like we did up here at the top. We're going to do the top part first, and then we're going to combine it with our dividing. So we're going to do this just like we normally would. We're going to multiply our numbers. 9 times 4 is 36 times, remember we add our exponents, 10 to the 4 plus negative 2 is 2. We need to put it into, well, we can't wait to put that into scientific notation. So we're going to wait on that and we'll put it into scientific notation at the end so that we have easy numbers to work with. So now we're going to put it over 2 times 10 to the 5th power, because that's this down here. I just moved it down. And then we're going to divide it out. So 36 divided by 2 gives you 18 times, and then we're going to subtract our exponents. So 10 to the 2 minus 5, which is negative 3. So we have 10 to the negative third power. Now we're going to change it to scientific notation. 18, we're going to have to move back 1. So it's 1.8. And we add 1. So back 1 adds 1 times 10 to the negative 2 power. Okay, so all we did on those ones is we just did them separately. We did the multiplying part first, and then we did the division of those second. So we just combined the steps together. All right, for J, this one is your power rules. So we're going to take our 3 and we're going to put it to the 4. We're also going to distribute it to the negative 5. So that's going to give us 4 to the third times 10 to the negative 15, because we multiply those exponents, over, we have to do the same thing for this one, 2 squared times 10 to the negative 14, okay? 4 to the third power is 64 times 10 to the negative 15, over 2 squared, which is 4 times 10 to the negative 14. We need to divide out 64 divided by 4. That's going to give me 16 times 10. Remember, we have negative 15 minus negative 14. Minus a negative changes to plus. So this is just the negative first power. Is it in scientific notation? Nope, it is not in scientific notation. So we're going to put our decimal. We're going to move back 1 and add 1. So 1.6 times 10 to the 0 power. When we have 0 powers, we don't want to cross those off. We want to leave them as 10 to the 0, so we know that we don't have to move anything or our decimal. We know exactly what number it is. We know it's just 1.6. Okay? So we're going to leave that 10 to the 0 there, just so we can keep it in scientific notation. If we were to evaluate the whole thing, we would just write 1.6. Okay? All right. Example 5, you have a word problem. So the distance from the sun to Mercury is approximately 6 times 10 to the 8th power kilometers. The distance from the sun to Pluto is 5.9 times 10 to the 9th power kilometers. Find the ratio. So the ratio means that we're going to have a fraction from the first distance to the second distance. So the first distance was 6 times 10 to the 8. Our second one was 5.9 times 10 to the 9th. Make that a 9. And we're going to do the same thing we've been doing. Okay? Divide these out. So 6 divided by, or actually no, we are not going to divide those out. We're going to keep that until the end, okay? Because we're trying to find a ratio, and we're not going to have decimals or scientific notation in this ratio. So our goal is to get rid of the scientific notation and evaluate it all. So I'm going to show you this step by step. So we're going to keep the 6 and the 5.9, okay? And we're going to figure out what our power is. So it's 10 to the 8 minus 9, which is 10 to the negative first power. This is where we want to follow our property rules, property of exponent rules. Okay, so 6.59, or 6 over 5.9, I don't know where I'm getting 6.59. 6 over 5.9 times, and this now we have to, because we can't have a negative exponent when we have a final answer. We're not dealing with scientific notation anymore, we're finding the ratio. So now we have to convert that. So that's going to be 1 over 10 to the first power, or just 1 over 10. And then we can multiply this out. So 6 times 1 is 6 over 5.9 times 10 is going to give you 59. So 6 over 59 is the ratio. Because we're looking for numbers, we're not looking for scientific notation anymore. So in order to do that, we have to get rid of all of that. So in this case, when we're looking for a ratio, no, we don't have decimals, so you shouldn't have no decimals. Okay, and it should be a fraction because it's a ratio. So no decimals in your ratio, and it should be a fraction. It just so happened that this one worked out nicely, that it was multiplied by 10, and there weren't any decimals left. But if there were decimals, we would have to convert them and get rid of them, okay? And there, you're going to have one on your homework like that, number 14, I think it is. So you're going to have to get rid of those decimals in the end. All right, example 6, we're almost done, guys. I know this is long. Write each number in expanded notation using powers of 10. So expanded notation, this is like each individual number and what it is worth. So because this is in the thousands place, this is considered 8,000 plus, this is in the hundreds place, so that's 500 plus 70 plus, that's in the ones place, so that's 2. So now we're going to have to write that out in expanded form. So that means I have to put each one of these individually into scientific notation. So that's going to be 8 times 10 to the, we're going to go 1, 2, 3 decimal places. So 8 times 10 to the third plus 5 times 10 to the second, because this goes 1, 2, plus 7 times 10 to the first, or just 10. And plus 2 times 10 to the 0. And there you have it. That is expanded notation. So when we write scientific notation expanded out, that is how we write it. Now that's the easy one. This one over here, this is the small number, the very, very small number. So we're going to write it just like we see it, okay? So this is 0.3 plus 0.09, because it's right here in this place, so we get rid of the 3, plus 0.004 for that one, because there's two other places in front, and plus 0.0006. Now we have to write those in scientific notation. So 0.3 times 10, and that would have to go over 1. So actually it would be 3 times 10 to the first power, negative first power, sorry. Okay, this one, 1, 2, so that's plus 9 times 10 to the negative 2 power. Plus, this one goes 1, 2, 3, so 4 times 10 to the negative 3. Plus, this one, 1, 2, 3, 4, 6 times 10 to the negative 4th power. And there you have it. There is your scientific notation written out in expanded notation. All right, very last thing that we're going to look at. Complete each statement by writing a power of 10. So first of all, we need to know 1 kilometer equals how many meters, and that is 1,000 meters. So to convert that 1,000, you're going to go 1, 2, 3. So it is 1 kilometer equals 10 to the third meters. Okay, so that is just 10 to the third. One milliliter, so 1 milliliter equals 0.001 liters. So this one is going to be 1, 2, 3. So that's going to be 10 to the negative 3 liters. Okay, so be able to convert those units. Okay, you should be able to convert them. You should be able to know what those are. We've done units. We've learned conversion of units and all of that good stuff in middle school. So hopefully you remember some of that. All right, that is it for your notes. So now it is time for you to work on your homework, and hopefully you should be able to get most of that done in class today. Have a great day. I will see you on Friday.